Thanks for CVC and all of the event organizers for allowing this to be virtual so that people like myself can tune in. And even though I'm not with you in person, I feel like I'm with you in spirit, and it's been really fun listening in so far. Just checking that the sound's okay before I continue. I'm guessing it's okay.
No problem. Yeah, it's okay.
All right, great, cool. So the contents of this presentation is organized into 5 sections: the introduction, framework, methodology, findings, and further work. So I'll start with some statistics first. So industry research shows that throughout the entirety of 2022, 53% of all construction invoices in the UK were paid late. Academic research also suggests that for payments between contractors and subcontractors, 46% of payments were paid late. So there's a bit of consensus with the industry and academic research. And also number 3, 44% of SMEs reported needing access to additional finance just to cover the rise in costs, in energy costs. Number 4, approximately 7 construction companies file for insolvency daily in the UK, which is 2,400 annually. The 2 suggested leading causes for this are lack of profitability and cash flow management. And also number 5, across 17 industries in the UK, construction contributes to the highest rates of insolvencies at 20% of the total insolvent population, which has been the case since the 1970s. So the governmental push for PBAs was most motivated by the demise of Carillion, the second largest construction company in the UK, which went into liquidation in 2018 with a debt of 7.1 billion. Of that 7.1 billion, 1.3 billion was owed to SMEs for unpaid work. If PBAs were used, then funds would have been protected against this. And in response, public sector clients such as Highways England have mandated the use of PBAs on all public sector construction projects. So I'll quickly explain what PBAs are. So figure 1 shows how in a traditional project, payments cascade down the supply chain. So from payments between the client and the tier 3 supplier, it can take up to 90 days. With PBAs, all the supply chain parties would be paid directly from the PBA. So payments from the client to the tier 3 would be capped at 30 days. Some related works for blockchain with PBAs. So a 2019 article collected interview data from senior construction practitioners knowledgeable in PBAs. It concluded that smart contracts could automate PBAs, but it only really discussed this at a hypothetical level. Number 2, there's a 2020 article that discussed blockchain for PBAs and provided an alternative where payments get frozen in a smart contract 1 month in advance. Now, I don't really see the freezing of project funds as a solution myself, simply because if the client and the contractor don't have funds available on payment execution date, then they're not really going to have it available 1 month in advance, simply because they just don't have any cash to freeze in the first place. And also, it's bad cash flow management practices to just freeze funds in a smart contract, simply because that cash could be utilized for better uses. Number 3, 2021 article deployed a PBA blockchain test application. However, it did not integrate a PBA trust deed, which is a very integral part of PBAs. It does not accommodate change orders, which happens very frequently in construction projects, and it was not reflective of the various payment approvers in the PBA system. The framework I propose in the application I propose addresses all of these problems. So I collected data from 2 perspectives, from the organizational and the technical perspective. For the organizational perspective, I collected data from via focus group interview with construction practitioners with working experience of PBAs and knowledge of blockchain. And then from the technical perspective, I collected data from computer scientists and software engineers with experience developing decentralized applications for managing payments. The strategy I used was a design science research approach, a multi-method data collection, and a multi-stage feedback loop, where I started with a framework and then I used the data to improve that framework afterwards. So I won't talk too much about the UI, simply because it'll just take me too much time to explain, and I want to present the findings as the primary focus. So on the left, though, is a screenshot of the trust deed smart contract. So a user would simply log into the application with their MetaMask wallet, and all they would need to do is click submit to send their details and their wallet address to the PBA trust deed smart contract. So with this, you would have like a KYC and whitelisting system to ensure that any random person can't just come along and just sign the trust deed. The trust deed smart contract also acts as a user control system. So when users sign it, it grants them access to controls to other parts of the application that would typically be locked. And the application also knows if you're a subcontractor signing it or if you're a tier one payment approver signing it via the KYC that happens before it. So only participants that are in the PBA trust deed would be allowed to approve payments if you're a tier one or receive payments if you're a subcontractor. This is another screenshot of that showing the cash out tab. If you scan that QR code, it gives you access to the application. It's just a standard web application, and you can actually test it out yourself. The cash out table showed on the right mimics what a contractor would normally produce. They would normally produce this on an Excel spreadsheet of some sort, but I've played around with putting this spreadsheet onto an actual smart contract itself. So this table would include all of the scheduled payment records, and then the different payment approvers in the PBA system would be able to interact with this payment schedule directly. And when each payment schedule receives a certain number of approvals, it would execute a payment from the PBA smart contract to the suppliers. So some of the findings, the direct quotes from the interviewees was that number one, after the bank has given a fully signed trust deed, it takes them several weeks to set up the PBA. Two, waiting for the bank to initialize the PBA is one factor that causes delays in projects. Now, if the PBA was set up as an MPC, so a multi-party computation wallet or a multi-signature smart contract, then this would limit the processing times of setting up PBAs because it could essentially be set up within minutes, essentially. Number three, another participant said that banks only keep PBA transaction records for 6 to 12 months. Now, I queried why this was the case, and they said they actually don't really know why, but the bank just sets a time limitation and says, after a certain period of time, the contractor or any suppliers that want to store the transaction records need to store it themselves. Now, the banks don't actually delete it from their system. What they do is they just archive the transactions and remove it from it being able to be queried on their system. Number four, current systems lack traceability with payment approvals and sign-offs. And another added, they frequently suffer reconciliation issues regarding managing cash book data, which the blockchain would mitigate through its single source of truth. Number five, another mentioned that the fact users are automatically reminded when tasks need to be performed immediately mitigates having to chase people for information. So this isn't really blockchain specific. This is more to do with the business logic of the application, where whenever an approval is required, the application sends an automatic reminder to the person stating that an approval is required and where in the application to conduct that approval. Number six, another mentioned that in the PBA trust deed, it will say which bank account to use for the PBA. There should be no problem in specifying a blockchain wallet as the PBA, provided the right KYC and insurance are in place throughout. Another mentioned that there's a plethora of project management software that does management tasks better than blockchain. So it's best to use blockchain for what it's good at, which is a settlement layer. Another stated how off-ramping stablecoins is where most of the challenges are. And lastly, someone else mentioned that stablecoins are not yet considered legal tender, but it should be ironed out when the stablecoin bill is approved. Now, this stablecoin bill they're talking about is a bill that was submitted to the UK Parliament that would approve stablecoins as legal tender. So it's currently at its final stage, and it's currently with the UK Parliament House of Lords. If the stablecoin bill gets fully approved, it would allow stablecoins to be used as commercial money, essentially. So you could pay suppliers with it, and they could use that to spend in the shop and buy goods in a commercial outlet. One of the other benefits of PBAs is democratization of it by using blockchain. So despite the UK government specifying that all supply chain parties are paid from the PBA, in practice, this isn't how it's exercised. And one interview commented that PBAs are only used for payments down to tier 2 because they're too complicated to set up and manage, and contracts between tier 2 and tier 3 are completely different, and that not all banks offer PBA services. Furthermore, they added that they have managed over 40 PBAs and none of them were used to make payments to tier 3. So PBAs in their current climate only benefit tier 2 because it's too complicated to set up and manage. And so tier 3 down to tier 5 would still be subjected to poor payment terms. which my application was looking to try and mitigate through process flow automation. So some of the process flow automations is that there's two main forms in PBAs: a payment application, which is used for payments from the client to the PBA, and the authorization statement, which is used for payments from the PBA to the suppliers. Now, currently, the contractor has to manage these forms, so they need to list all of the liabilities due for each milestone payment. They need to send this form manually to all of the payment approvers to get their signatures. After they've collected all these signatures, they package them in an authorization statement. They send it to the bank. The bank needs to verify that the transaction signatures or the approval signatures match the signatories of the PBA trust deed. After that happens, they execute the payments from the PBA. Now, this is a lot of payment processing stages just for executing payments from the PBA. And the application I propose automates the payment application and the authorization statement, so the contractor no longer has to manually manage these. Some of the challenges identified was that one, the findings uncovered that the proposed application needs to interoperate more effectively with existing construction software. Two, despite blockchain providing cost-free technology infrastructure by being open source and open license, it suffers from a lack of formal adoption frameworks and skill shortages in DApp developers, making the technology expensive to utilize in the current climate. Another stated that another crucial finding is that banks can block cash deposits from cryptocurrency service providers if they deem them high risk. So this could actually make the payment problem worse because supplier funds could potentially be withheld while they undergo AML checks. Number four, DApps suffer from a lack of centralized accountability for damages caused by hacks or incorrectly coded smart contracts. However, in response, one particular wallet DApp, Credo, has addressed this problem and offers up to 600 million in insurance coverage for any funds or lost stolen through their debt. So some of the further work. So I'm currently working with a new DApp developer, a new startup company that was founded just a couple of months ago. They're called BuildX Blockchain. Now, this BuildX is different from the company mentioned yesterday, who's also called BuildX. Just out of coincidence, they share very similar names, but they offer different products. So BXB is looking to develop decentralized PBAs and receivables finance. The infrastructure of BXB is provided by Maple Finance, who's a blockchain platform that provides institutional lending with loans settled on the blockchain. Credo specializes in MPC wallets and multi-signature smart contracts. They would be the ones that would host the decentralized PBA, and Pound Token would be the stablecoin provider. I've had calls with Maple, Credo, Pound Token, BXB, and the main contractor discussing the viability of hosting PBAs on the blockchain. And once we develop our infrastructure a bit further, we're planning to conduct a pilot study with the main contractor. That's all of the presentation slides, and I'm more than happy to answer any questions. Thank you for listening.